Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of sequence and series. And if I talk about the question which is given to us here from this topic, the question tells us let A1, A2, A3 be a geometric progression of increasing positive numbers. So basically we understand that R has to be greater than 1 because it's told to me increasing positive numbers. Further, they have told us sum of its sixth and eighth term is 2. So sixth term and eighth term, the sum for that is 2. And product of third and fifth term, it is given to us is 1 by 9. So we have been asked to find the value of expression that says 6 times second plus fourth term and fourth plus sixth term. So we need to find the value of this entire expression, that is 6 times of second plus fourth term and fourth plus sixth term. So let's try to solve this idea. Before that, if I see the answer choices that are given to us for the values of the expression, they are 2 root 2, 2, 3 root 3, and 3. So we need to find out what is the correct answer for the expression that is asked to us. So to find the correct answer for the expression, we'll first have to find what is the value of first term and what is the value of r that is getting multiplied here. So to get that, if I write my geometric progression, I know that my first term is A. To get my next term, I'll multiply with R. So after that, again to get my next term, I'll multiply the previous term with R. Again to get the next term, I'll multiply my previous term with R. So basically the ratio is constant. So nth term in this case, we know it is A R raised to n minus 1. Because if I talk about the first term, we don't have R. For the second term, we have 1 R. For third term, we have 1 less R. Fourth term, we have 1 less R. So basically for nth term also, we have 1 less R. So that gives us that the expression or the formula for nth term becomes A R raised to n minus 1. Now, if I try to understand with my conditions given, it says A6, that is sixth term plus eighth term. The sum for that is 2. We know sixth term, I can write that as A R raised to 5. And the eighth term, I can write that as A R raised to 7. The sum for that is given to us as 2 here. And further, the second condition that was given to us here is third term and fifth term has the product of 1 over 9. So third term I can write that as A R square, and fifth term I can write that as A R raised to 4. That is basically equals to 1 over 9. So that gives me A square R raised to 6 is equal to 1 over 9. So further, if I try to simplify that, I can write that as A R cube the whole square, which is equal to 1 over 9, or I can write that as 1 over 3 the whole square. So from here I get A R cube. If I take the square root on both sides, I get A R cube is nothing but 1 over 3. So you get the value of A R cube from this expression. Now once we have A R cube known, that is 1 over 3, if I use this idea and solve this further, A R raised to 5 plus A R raised to 7, it is given to us as 2. From here, I can write A R raised to 5 as A R cube into R square. A R raised to 7, I can write as A R cube into R raised to is equal to 2. So from here, I know A R cube is 1 over 3. And here also A R cube is 1 over 3. So you get this understanding here. Now, once you have here this idea, I know R square plus R4, both of them have same denominator 3. So I can write that as further R raised to 4 plus R square is equal to 6. That gives me R raised to 4 plus R square minus 6 is equal to 0. Now further, if I try to solve this quadratic equation, I can split my middle term as plus 3 and minus 2. So I can write that as R raised to 4 plus 3R square minus 2R square minus 6 is equal to 0. Now in this, if I try to take common from this ideas, I have R square common. r square plus 3 minus 2 r square plus 3 is equal to 0. So you have this quadratic simplified that says r square plus 3 is equal to 0 or r square minus 2 is equal to 0. So you get this term simplified. Now, if I equate it with 0, r square plus 3 is equal to 0 or r square minus 2 is equal to 0. So we get from here r square is equal to 2, and from here I cannot get a positive value for the square of something, and we are finding the square of real part of the common ratio. So I cannot have the square of anything as negative. So we have to reject this expression. So with that, I get the answer for the question that r square is basically equals to 2. And with that, since we have been told that r is greater than 1, I know I have to just take the positive value for r, and that is root 2. So if I take the square root on both sides, I get the value of r, that is common ratio, as root 2. Now once I have the common ratio here as root 2, I already have the formula here with me that says a r cube is 1 by 3. So when a r cube is given to me as 1 by 3, I get a into root 2 cube is equal to 1 by 3. That gives me a into 2 root 2 is equal to 1 by 3. And further, if I solve this expression to get the value of a, I get a as 1 over 6 root 2. So a is basically 1 over 6 root 2. Now once I have the value of a, I also have the value of r. If I just find the value of the expression that is given to us here, that is 6 times second term plus fourth term, and the second bracket fourth term plus sixth term. So you get this 6. A2 is nothing but a into r. A4 is nothing but a r cube. Here you get a4 is again a r cube, and a6 is a r. So from this expression, if I solve this further, I get 6a r common, and you have 1 plus r square. Here you have a r cube common, 1 plus r square. So if I put that, I get 6 times ar into ar cube, so that is a square r raised to 4, and you get 1 plus r square into 1 plus r square, that is 1 plus r square the whole square. Now you already know the values of a and r, just substitute that. We know a square. A we got that as 1 over 6 root 2 the whole square. R raised to 4, r raised to 4, if I see, I know r is root 2. So r raised to 4 is root 2 raised to 4 into 1 plus r square. R square is root 2 square, the whole square. So you get this as 6. This becomes 1 over 6 into 6, and root 2 square is 2. Here you get root 2 raised to 4, which is 2 square, that is 4. And here you get 1 plus 2, 3 square, that is 9. So if I cancel out some common terms, this gets cancelled, 2 ones, 2 twos, 2 ones, 2 threes, 3 ones, 3 threes. So you get the answer here as 3, and that becomes the answer for the question asked to us. So if I see, the answer matches with option D. So D becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions. So we just use the idea of the basics of geometric progression, that nth term is given by a r raised to n minus 1. We substituted that in the two conditions given, and from that we get the value of a and r after solving the quadratic. We got r as root 2 and a becomes 1 over 6 root. So once you get a and r, you put that in the question asked to you, and once you get that, you get the final answer to become 3. That matches with option D. So D becomes the correct answer for the question given to us here. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we're going to continue our series of questions on 11th, 12th, as well as JEE mains. So stay tuned for more videos to roll out. Also, do like, share, and subscribe to my channel. Do share these videos with your friends who are involved in the preparation of questions on Jira. So they can also take the benefit from these questions which we are solving on everyday basis. Thank you.